Hey, and welcome to your Fix It Fast audit, which I guess probably isn't quite true because this isn't your site. This is an example site. What I've decided to do is to demonstrate to potential clients such as yourselves what you could expect from your own site speed audit, your own sort of Fix It Fast. Um, I've decided to do a free audit for a local charity. Now, it's a charity that means quite a lot to me. It's the Yorkshire Air Ambulance Service. I've never actually used them personally, thankfully. But my amazing, wonderful little sister actually works for the Yorkshire Air Ambulance Service. So what I thought I would do is do a bit of charitable work by doing a free audit for the Yorkshire Air Ambulance Service, but then making that available to you as a potential client so you could see what to expect. What you'll find is that there's no real script, no real structure, because what I'm doing is basically a real time sort of live audit of a site, sharing those findings on a screencast. Now, the screencast will get tidied up, it will get edited and trimmed down, but it is a fairly organic process that we're about to go through. As well as getting the screencast at the end, you would receive an email with any code examples or any links or any further reading, any further materials. Um, but basically, what we're about to go through now for the Yorkshire Air Ambulance Service is what I would go through for you. So if you like what you see, this is what you could expect. And I really look forward to working together. So let's dive in. So the Yorkshire Ambulance Service is a local charity. Yorkshire's a beautiful part of the world. It's where I live. And they help people in the region in emergencies and in sort of accident scenarios. You can see from the video on screen right now, they run a fleet of aircraft, and it's just an amazing charity. But as with any charity, it costs a fortune to keep them running. So I think what would be a nice thing to do is just make their site a bit faster. Hopefully, that might lead to more donations. It might help them out in some way. But let's dive in. So what I normally would do when I start any kind of audit on any site is I will check the data I have available. So sometimes a client may give me access to things like New Relic or Speed Curve or Search Console. For the Yorkshire Ambulance Service, I don't actually have access to any of that at present. So what we're going to do is we're going to look at CruX, so the Chrome User Experience Report. To do that, I always use a site or a tool called Trio, built by a friend of mine called Alexia. It's an incredible tool. And this is just showing me the real user data from Chrome visits to the Yorkshire Air Ambulance website. Now, what we'll see right off the bat is this is a huge problem. Time to first byte is really, really quite bad. We've got a 2.5 second budget for largest contentful paint, and we've already lost 2.2 of that to time to first byte. It's going to be virtually impossible to get a 2.5 here without solving this. So my very first bit of advice to the Yorkshire Ambulance developers or the company that works on the site is look into your back end problems. So time to first byte is really crippling us here. It has gotten a little better, sort of around late fall, early winter. It was hovering around 3 seconds. So it has somehow got better. I'm not sure exactly what was done, but this needs to keep going in that downward trend. So the Yorkshire Ambulance website is a WordPress site. So it's going to be the usual kind of suspects, looking at better quality WordPress sort of caching. It may be on shared or sort of commodity hosting. What I'd recommend is perhaps speaking to your agency, your developers, and see if they can move you to sort of a more, I don't know, more premium hosting provider. It may be worth looking into providers that do sort of good deals for charities. But whatever you do, you need to basically look at this back end stuff. Unfortunately, especially from the context of this audit, I have zero visibility on that. So that's going to be a main sticking point for us is this time to first byte issue. We then have another 600 milliseconds between first byte and first contentful paint. So that means we've got about 600 milliseconds of render blocking head tag sort of time. That sits around the region I would expect. That isn't sort of scaring me. And then only another sort of 200 milliseconds to get from first contentful paint to largest contentful paint. This really small number tells me that a lot of our largest contentful paints will be textual, or we've just got really well optimized, quickly delivered images. And we can quickly corroborate that or see if I'm correct by scrolling down. And what we should be able to see is if we go to latest, what we'll see here is LTP image subpart. So um, images are loaded really quickly. So if it is an image LTP, we'll find that the image is discovered within about 400 milliseconds. It's fetched within 150, and it sits waiting to be displayed for 225. So these numbers here are all really nice and condensed. They're nice small numbers. What we can see is that, again, we're just losing the bulk of our time to first byte. Okay, so let's stay on the time to first byte trend. Let's take a look at this. So fixing time to first byte, and in fact, I will add this to the email at the end of the audit. But Time to first byte could be any one of a number of things. This is actually a non-exhaustive list, but your time to first byte could be any of these things that I currently have on screen. So it's a really rather complex thing to solve. Changing hosting provider is sort of it's not the most straightforward thing in the world. Anything we're going to have to do is going to be relatively high effort. So what I want to look at first is in-browser mitigations. What can we do in the browser to sidestep these time to first byte problems? We're going to have to pay the cost at some point, until we actually fix the root cause of the problem on the back end. We will have to pay this price at some point. But can we pay it out of band? Can we pay it up front? Can we pay it ahead of time? Is there anything we can do sensibly to sidestep these issues? So let's take a look. The first thing I would recommend is making sure you've just got a decent caching strategy. If you're going to do something, try and only do it once. So what I want to go and look at is the caching policy for the HTML pages on this site. I've just switched from my regular Chrome profile to my performance profile. If you're more interested in that, or if you're interested in learning more about that, I'll add a link to a video course. But it's just really it's quite sensible to have your own separate, isolated performance testing profile, no plugins installed, etc., etc. So, because we want to look at the caching policy, what I want to do is make sure I've got caching enabled. This is a bit of a what's the word? A bit of an oversight. Most performance engineers tend to leave this on, but none of your real users will have disable cache ticked. So there's no point really testing the site. For the bulk of your testing, there's no point testing it with disable cache enabled. So what I'm going to do is I'm going to do a hard refresh, which simulates the first time landing on the site. And we can already see there, the time to first byte was really quite high. So let's scroll up. So first byte time was, 2 seconds? You can see there the waiting for server response. So 1.8 seconds plus a bit of queuing and stalling, waiting for a connection. But yeah, that's just really, really high. We've lost 2.2 seconds of our 2.5. We need to sort of mitigate this as best as we can. I'm throttled to slow 4G, which I found has previously given me. Let's just try that again. So it has previously given me LTP timings close to. Okay, maybe I'm going to switch this to fast 4G. What we want to do is every time I refresh, I want to land on an LCP that is similar to this 3.8. Okay, that's kind of close enough. What you always want to do is run tests in your local environment that feel like they mimic live. So it looks like somewhere between slow and fast 4G is where I should be looking at. I think slow 4G is just a bit too slow and fast 4G is just a little bit too fast. But that's by the by. Let's stick with it. So I want to look at the caching strategy. Let's look at the HTML. They were all hard refreshes, so I'm expecting to get 200 responses. So if I just do a normal refresh, I would hope that would be a 200 from browser cache, worst a 304. No, that's definitely hit the network, hasn't it? So, yeah, it's transferred 38 kilobytes. That definitely hit the network. And the reason for that is we don't have any caching at all. Well, that's not technically true. What this tells us is store this response for 0 seconds. And once 0 seconds has elapsed, you need to go and revalidate it with the server. Now, the thing is, we don't seem to be attaching any sort of E tag or last modified headers. So what that means is we don't actually have any means of revalidation. So what we ideally would do in this scenario, this is a non-ideal scenario, but in this non-ideal scenario, the next best thing we could do is attach either a last modified or an E tag header to this response. So that when we go back to the server can say, well, you haven't changed. So yeah, you've come all the way back, but just you don't need any fresh HTML. Reuse the stuff that's in your browser cache. Because we're not emitting ETAG or last modified headers, we don't even get a chance for that quick return 304. So unfortunately, on every sort of page view, every subsequent page view, this is going to be a full round trip to the server. This is a relatively static site, so we could cache these responses for at least a few minutes. So that's one thing I would look into immediately is tighten up your caching strategy. Add a max age directive that's going to be, at least 10 minutes, probably longer. You could probably get away with like I don't know, a couple of hours to a day. As well as that, emit ETAG or last modified headers so that you don't force a 200 response when you don't need to. It will allow you to have a latency bound 304 response, but even that's going to be a lot faster than building the response on the back end. So first thing to look at is caching. Okay, then. So on the subject of caching, let's look at the next thing. So we've got the sort of typical HTTP cache, which we all know is just browser cache. I'd be interested to look at the back forward cache. Because this is a multiple page app, because this is a WordPress site, we get hard navigations. The good news about that is hard navigations can be optimized a lot easier than soft navigations can. So let's go and see if we can make use of the BF cache, the back forward cache. So amazing. So that's great. That means that once someone's visited a page already, if they hit the back button, they should find that the subsequent page load, the going back, is basically immediate. So that page load took quite a long time, 2.77 seconds. If I hit the back button, though, what I should see is the home page should be instant. That's pretty close. That's pretty good for me. Zero point 0.4 second LTP. So that's great news. We're not doing anything inadvertent to limit our access to the back forward cache. I'm really very happy with that. Okay, the next thing I would like to look at when it comes to mitigating time to first byte is speculation rules, which actually Yorkshire Ambulance already use. So I'm really happy to see that implemented. We can see, so actually, yeah, just for those who aren't aware, the speculative loads or the speculation rules API, what that allows you to do is basically fetch pages in the background. So you could tell the current page, while someone's browsing me, go and fetch the next X, Y, and Z pages. And that means that by the time someone clicks on a link to that page, hopefully, ideally, the page is already on their machine waiting for them to view it. So we have some speculation rules sort of in place. And we can see that we've attempted to, we've got 29 speculation rules. These are all the URLs that are a target of that. And if you look at the rules themselves, we will see any first party link. Any first party link except these should be prefetched conservatively. Now, conservative is on pointer down. So when I start clicking a link, the browser, Chrome, will go and start fetching the the HTML in question on that mouse down. Now, my fear is that for Yorkshire Ambulance, that's a bit too conservative. The sort of difference in time between a pointer down and actually just requesting the page, it's going to buy you like maybe a few milliseconds. And because Yorkshire Ambulance, because we've got quite high time to first byte, over 2 seconds in some scenarios, I feel that conservative might not be enough. We're only going to shave a few milliseconds off of a 2000 millisecond time to first byte. I would suggest bumping this up to moderate. And for certain pages, like your donation page, very important pages, I'd probably have that as its own separate rule, which would be pre-rendered immediately. Those are things to toy with, but let's see how this works. So let's look at 29 not triggered. Let's go to the main nav. Let's look at our impact. I haven't been to any our impact pages yet. So what you'll see is that our impact, when I clicked on that, we've got that switched to ready. So what I'm going to imagine is this our impact link, this yellow link, is actually an A with an H ref in it, but it's been hijacked with JavaScript so that on click it actually opens the dropdown. But that should be actually a link. Exactly, it is. So you can see that the speculation has worked. This doesn't currently act as a link because, like I said, JavaScript has sort of taken over. But if we click on Incident Roundup, and can we find Incident Roundup in here? Can't see it currently. Yeah, we got Incident Roundup. So keep an eye on this one. When I click Incident Roundup, that should say running and then hopefully ready. So you see, that really wasn't that much faster, was it? If we look, we still got a 2.7 second time to first byte. So even though we are using speculation rules, I think given the time we need to make up, they aren't quite aggressive enough. So what I'm suggesting there is bumping that up from conservative to at least moderate. But then for certain pages, especially things like your donation page, where you're really trying to drive traffic, maybe go as far as pre-rendering that one immediately. But with that said, really, really impressed and really happy to see we are using speculation rules on the site. I just think we could bump that up a little bit more. One thing I will do is in the final email, I'll send you a link to this bit of self-promotion. But I wrote an article about how you can layer speculation rules up so you can use them quite sensibly, and you can sort of opt into different sort of different levels of speculation. So it's not going all out immediately, but at the same time, it's not acting as conservative as we currently are. So yeah, speculation rules, super impressed, super happy to see them in there, but I think they could be working for us a little bit harder. Right, let's move on to the next thing. So we took a good look at time to first byte and its mitigations. Next thing I'm going to do is look at some specific URLs. This is basically for the entire origin, Yorkshire Ambulance. What I've done is I've added this to my actual paid for Treo account. And what we can see is that we've only got 11 URLs in the data set. None of them fail CLS or INP. It's all LCP bound. What I'm going to do, therefore, is ignore INP and CLS entirely. And what we'll do is we'll look at loading. And what you can see here is that, yeah, the fastest time to first byte we've got is 2 seconds. The fastest LCP we've got is 2.6. So we don't have anything under that 2.5 threshold. And we've got, pushing as far as 4.5 here. So what I did is I copied and pasted all of these URLs and ran them through web page test. Here we've got a visual comparison of them all. And what was I running? I think I was running these tests out of London on a 4G connection. And we can see that basically we're all bound to this really bad time to first byte. So let's take a look at the home page to start with. Let's look at test run details and see what's going on. Um, LCP for the homepage was 6.6 seconds, which is actually a little slower than the real world. So I ran this over 4G. I could have probably run this over LTE. That may have been a bit more of a realistic thing to do. But because this is a synthetic test, I'm not really bothered what the numbers say. This wasn't a real user. This doesn't affect a real user experience. What you should see your synthetic tests as is just a bit more a size and shape kind of thing. So it's more of a vibe than looking at the actual numbers. So what we see is we've got bad first byte time, bad first contentful paint, and therefore bad largest contentful. So let's look at what might be causing us some of these problems. First thing I'm seeing is loads and loads of render blocking sort of style sheets in JavaScript. And then unfortunately, yeah, we can see here we do have third party. Yeah, okay. This I could see this coming a mile off. Right. So what we've got is we've got some third party stuff. So Cookiebot that might have to stay render blocking. I can't really see how we'd self host that unless we were to proxy it through our own domain. But yeah, that's going to be render blocking. Um, it's cacheable for one odd number. 18 hours. So yeah, capital for 18 hours. So that's not the end of the world. That means as we navigate from page to page, every subsequent page view, this should be coming from browser cache. But the biggest thing I'm worried about is Typekit. Typekit, I know what Typekit do. This is really unfortunate. So Typekit, cacheable for 10 minutes. Not terrible. But then, yeah, okay, it's got a really long stale while revalidate. So again, we'll take a hit once, and this should be sort of fairly plain sailing on subsequent page views. But the major problem we've got with Typekit, and this is just by design, one of the first things they have in there is an import. And an import is really, really terrible for performance. It just adds to our critical path. So what I'll do is I'll illustrate that for you. Customize waterfall. So what we want to do is we want to look at request number one, the HTML. We want to look at request number 39 and 54. So 1, 39, 54. So what we can see here is that critical path is massively exaggerated. We've got 3 seconds lost to time to first byte. We then lose 852 milliseconds to fetching the initial typekit file. What you'll note is use.typekit.net needs DNS, TCP, TLS, so we lose a load. In fact, we lose the majority of our time to network negotiation. Then the main thread's doing some stuff. While the browser's running JavaScript, it can't be parsing CSS. So what's probably happening here, and you can see a bit of pink JavaScript execution. The browser cannot actually parse this style sheet until the main thread becomes available and a recalc style task can be scheduled. That doesn't happen until 4.5 seconds, at which point we lose another 750 milliseconds to the critical path. And again, most of that is spent on pure latency and network negotiation. Then we get a huge recalc style event before we get our first paint at 6 seconds and our largest contentful paint at 6.5. My advice here would be twofold. One, you could move the typekit file to your closing body tag. That means it only render blocks the last bit of the page. But the risk you run with that is you may see a flash of fallback text. Um, but that will make the page a bunch faster. It will remove that Typekit file from your critical path. Other things I would definitely do is I would pre-connect key.typekit.net, and I'll put this in the email. I'll give you all the code snippets. And what I'd also try and do, and keep an eye on it because it might not work forever, is I would actually preload the second file. So what I would do is I would say link rel equals preload as equals style, fetch priority equals high, href is this file here. Now, like I say, the risk we run into is that if the use.typekit.net file ever changes the URL it imports, what we'll end up doing is importing this file, sorry, preloading this file completely unnecessarily, and then still fetching the new version of the new file inbound very slowly later. So it's quite a medium risk solution, but I'd certainly experiment with preloading this file from the HTML rather than allowing the sort of parent file to find it. And then the other thing I would do is I would just self-host Font Awesome. There's absolutely no need for that to be on the Font Awesome origin. Just drag that over to our own page, our own server, and load it as first party. Okay, what I actually decided to do was to run an experiment, a web page test experiment, doing that preload. So not doing anything else, so not self-hosting Font Awesome yet, doing nothing else at all, just preloading your Typekit second CSS file. This test led to a 1.3 second improved LCP. The experiment in question you can see right here. All it is did a find for a closing title tag and replace it with a closing title tag and that style sheet preload. And we can see that has bought us an extra sort of 1.27 seconds. Definitely worth looking into this. And maybe even moving the Typekit sort of CSS to the closing body tag. The only problem with that is that will make Safari slower. So it may not be the right solution for all browsers. But yeah, Typekit is just going to be slow by design, I am afraid. So looking back at the homepage, we do have it's a video that's constantly running there. So this video, it's a bit of a strange one actually because there is a poster image. We can see the video element has a poster, and that doesn't result in a 404 either. There is a poster image on the video, but for some reason, sort of web page test is complaining there isn't a poster image. There absolutely is. That poster image is yeah, what 1920 by 600.jpg. So we try and find that real quick. There we go. So there's your poster image, and it was the 83rd request. Now, the reason this request happened so late is because it comes out of the poster attribute, and the preload scanner cannot read the poster attribute. The preload scanner only looks for things like hrefs with sort of style sheets, sources on images and scripts, that kind of thing. The preload scanner doesn't look at the poster attribute. So what that means is it's not until a parser actually gets to that video element in the page that it sees a poster attribute and it's like, I need a poster image right now. So this is probably going to go from low priority initial, because the browser's like, yep, I haven't been told this is important. I'll find it when I get to it. When the browser eventually gets to it and realizes that this element is actually above the fold and it's like a hero image, it will change priority to high because the race is on. But the problem is it happened way too late. It took until the 83rd request for us to actually go and get that image. It's a bit too late when it could have been our LCP. So, and indeed, it was our LCP. I don't know why it's complaining. It says no poster image, but we can see that the LCP was an image. And because we haven't started fetching a video file yet. If you look at these requests, you can't see any huge video files. So I don't know what web page test is complaining about. The LCP was definitely the image. So what I did is I modeled another experiment. And what I did with that experiment is I just added a preload for the poster image. Now, it can be quite difficult adding preloads to your head tags because it means your head tags have to be aware of your in-page components. What you'd have to do is sort of have some WordPress logic or some way of saying, if you're on the homepage and this video component is the current hero image, then add this preload to the head. It doesn't need to be as complicated as that at all. Basically, what you can do is you can put link rel equals preload anywhere you want in the body tags. So that's all I did. What I did with this experiment is I found and replaced video with link rel equals preload, path to the image, video. So what this has done is it's just put the preload immediately before the video tag. That means you can put your preloads inside the component. They don't need to be in your head tags. You can keep this stuff all together. And it does work because just by preloading that image, it's not a great deal, but it's 300 milliseconds faster. So if we combine this 300 milliseconds here with the 1.3 seconds for preloading Typekit, we're already like 1.6 seconds faster. That's a huge, huge number. So I would definitely recommend doing this. And the cumulative effect of those two preloads is going to be getting us way, way closer to the green. So just coming back to this visual comparison, one thing I noticed that was quite odd is a lot of these pages seem to be quite devoid of imagery, which is fine. Maybe they are, no images above the fold. But certain pages to me look like they could be a bit broken. So all I'm going to do is just check out certainly this page here, incident roundup, and definitely this page here. Um, so that maybe that is just what the background is. Copy link address. Let's go and look at this in the performance profile. Oh, I was already there. Yeah, so that is basically all the that is all the back. So that's not broken. It's just a bit of an unusual hero image, not very engaging, I must say, but that isn't broken. That's fine. Let's look at the other one. This one does look like something's missing. Um, so let's go and take a look. Again, we can see we're running into those high first byte times. Um, so even though a lot of the assets coming from disk cache, that still took 1.8 seconds, leading to I mean, we're in time, 2.17 seconds, but in the real world, we can see this is landing more like 3.5, well, 3.3. So definitely need to fix this. But yeah, this page on desktop has a huge sort of hero image, which isn't present on mobile. That does. Oh, this page actually does just unfortunately look a little broken, doesn't it? Like if you look at the entire header up here, it does just look a little broken. So maybe that's something to look into. One thing I'm a little concerned about is this image is clearly quite large, and I worry that we might still be fetching that image on mobile, even though we're not displaying it. So that might be a bit of a opportunity for improvement there. So let's just try and find this image. So it's a background image, and it doesn't seem to be applied with any kind of um, media query. So this may well be happening. Ruler network panel. Okay, so again, if at all possible, if blog posts do kind of follow this background image pattern, if they do have this kind of general design style on blog posts, much like with the poster image on the homepage, just preload this. We can see its initial priority was quite low, and then it was eventually requested with high. This should be high, high, and it should be yeah, we should be requesting it much sooner than what we are. So I would just preload that with fetch priority high because background images are just pretty bad, pretty slow anyway when it comes to performance. Or what I'm going to do is see if we have fetched that image on mobile. Yeah, so unfortunately we have fetched that image on mobile. Let's just double check it is. Is it the correct? Was it the same image? Okay, no, no, no. So we just got lots of images with a similar name, I guess. So what's the exact name of that image? Okay, so thankfully, we didn't fetch that image on mobile. That is good news. So we're not doing anything wasteful there. Quite happy to see that. But these pages do just unfortunately seem a little broken on mobile. That's not a site speed thing. That's just something I noticed in that web page test. Right, let's move on. Another really small thing I spotted, it's very innocuous, but we've got this bit of functionality here, which is way down the HTML. So if you look where my scroll bar is there, this is right towards the closing body tags. In fact, I wonder if I could just, yeah, right towards the end of the page. So what this does is it basically tells WooCommerce or anything that wants to basically use this class that JavaScript is available. The problem is this is an inline script. So it means that everything before it, everything way up there has to be parsed before this script executes. And it's not until this script executes that we are aware that we have JavaScript available to us. So basically, what we want to do is run this much, much sooner. So what I'll do is I'll demonstrate the problem as it stands right now. So I've enabled local overrides, and what we'll do is I should be able to edit this file. It isn't letting me. That's hyper annoying. Um, okay, here we go. Performance mark, and then just something really obvious that we can find foobar as. And what I'm going to do is we're going to run a quick trace and we'll find out when this actually fires. The point at which this fires is the point at which WooCommerce and anything else that depends on that class knows that we do or don't have JavaScript. And that potentially could be way too late. In fact, there's every chance that WooCommerce may have fired before that class has been attached. If WooCommerce is asynchronous and defined before that inline script, there's every chance that WooCommerce is going to not be able to pick up the class at all. Um, Obviously, if our CSS is using it, we may end up getting like a restyle of the page because the CSS that's defined first will think that JavaScript isn't available. Then really late in the page, and I'm talking 3.19 seconds, we finally find out that JavaScript is available. So anything like that, they're a bit of a relic, but if you are using these JS/Node.js classes in your HTML, um, put them really early in the head. That brings us on to the next problem, though, because what this is doing is it's attaching to document.body. So we can't put this in the head. If we put this in the head, we just get an error. In fact, I'll show you what I mean by that. Let's put it early in the head, after the character encoding, perhaps. So if I run a trace now, this isn't going to get, this is actually going to give us an error. So I don't even need to run a trace. I can just refresh. This should throw us an error because there is no body, right? The body isn't attached yet. This is a synchronous script. All the browser has built so far is an HTML and a head and a meta and this script. That's why we can't use that. So if we want to use this script as is, we'd have to go to the body tags and we can put it as the first thing there. However, the problem with that is, remember we had 3.19 seconds here. The problem we're going to have now is that this isn't going to get much faster. We've still got all of the parser blocking head tags to contend with before we attach this class. So I'm sure you probably preempted where I'm going to go next with this, but let's just take a look at what happens. And let's see. It's basically, what, 14 milliseconds faster? Not really worth the effort, is it? So um, the problem we've got here is that, yeah, not 14. Sorry, was it my 140? Whatever it is. It's not much faster, is my point. It's really not much faster at all. So we're always going to be painted into a bit of a corner with this particular snippet. So what I'm going to suggest we do is put it back here, but instead of attaching it to the body, uh, attach it to the HTML tag, uh, document element. And once we swap document.body for document.element, we just need to add the class to the HTML element now. So we need to have this to be findable in order to be replaceable. And we can verify it worked because we can see class equals WooCommerce.js. And now what's going to happen, we run a trace. This should be substantially faster. We've still got all of the times to first byte issues to contend with. So this timestamp will still be it'll still include whatever our round trip for time to first byte is, but it still should hopefully be at least a decent chunk faster than it was previously. And let's have a look. Okay, it ran at 1.79 seconds. So we've gone from about 3 seconds to about 1.8. But what we can see is that's fired virtually immediately after time to first byte. So now, virtually as soon as the page is available, we know that JavaScript is running and JavaScript is functional. So a little sort of thing, anything that sets the page up, anything that tells other things about how the page is either parsing or what's available, try and get those fired as early as you can. Move those earlier in the HTML. And as you can see, we had to make some subtle modifications. In order to move it to the head tags, we had to look out for document element rather than document body, but that's no big deal. The tiny little thing I noticed is this nav, not only is it really slow, it does give us really subtle layout shifts. It's not too much, but if we keep going, basically the fact it's giving the layout shifts, it's not causing the score to go up, so it's not actually that critical. But just for the sake of being super duper thorough, what we're doing here is we are animating left. So you can see left is set to 0 and it was previously set to left 100%. What we need to do is animate transform. So we transform, transform, and it was left 0, so it'd be translate x, I guess 0, and then replace this left here with, it won't let me, transform, translate 100%, translate x. And then, just as a bit of best practice, avoid putting transition all. Whenever you do that, it's going to try and transition, well, everything, which means it's going to try transitioning top and width and all this stuff. Be more explicit. So never, very, very, very rarely, almost never. I don't want to see you putting transition all. Um, we want transform. So what we should hopefully see now, if we clear this out, no layout shifts whatsoever. This hasn't made much of a difference in terms of the actual end user experience. It didn't feel particularly sluggish to start with. This is just nitpicking. This is very, very sort of thorough sort of animation kind of stuff. The only one thing I would suggest is 1 second is, someone's in an emergency. You can't be waiting 1 second for a nav. A third of a second, yeah, that feels way more appropriate to me. I'm not going to bother looking into it, but it does just look like the nav dropped a bit. If you look, it drops down a little bit when it translates back in. Um, but I'm not going to bother looking into that. That's really sort of nitpicky, and that's sort of out of the scope of this. But yeah, two things to take away there is don't transition anything like top, left, right, anything geometric. That will cause layout shifts. And be very, very wary. Almost never should you use transform transition all. You should be more explicit with your transitions. Another thing I would just say is get rid of this accessibility overlays. I'm not going to go into too much detail because it's not really my area of speciality, but ask any accessibility professional on the planet their opinion on accessibility overlays, and you're not going to get very favorable feedback. Um, Accessibility overlays, I mean, this is costing you money. I would save some money. I would get rid of this. I would fix your accessibility issues yourselves. I did run a bit of a Lighthouse accessibility sort of report on this. And the problem is, like, unfortunately, your color scheme isn't very good contrast. So I know it's kind of your brand, but this color scheme isn't great contrast. That could be fixed, but yeah, you might have to sacrifice some of your branding. The other thing as well is make sure your CMS users are putting decent alt text in. So this link is just an image. There's no text inside the image. This has great alt text. Look at that. Whoever wrote this they deserve a pat on the back and the afternoon off. But if we go and look further, we will find that some of them, this one has no alt text at all. So what this means is this link, there is no link text in there. A screen reader is going to get to this link, and what it will actually do is it will probably read out the source attribute. It'll probably read out HTTPS www Yorkshire Air Ambulance. That's really not a great experience for assistive technology users. So for the most part, you're doing really well. Like this alt text was incredible, but you've got none at all here. That means that this image is just it's not gonna have any text for a screen reader user. I'm gonna presume that this link, yeah, this is a link. But all that says is read more. So again, for a screen reader user, a page full of read mores is not a great experience. If you could wrap this whole thing in a link, maybe that would be a nicer experience. But basically, what I'm trying to say here is images do need alt text unless they're decorational. But as this image is directly inside a link, it's imperative this has alt text because that link currently has absolutely zero description. I think for now, the last thing I want to look at is your tag manager. Basically, we've got some duplicates. So I'm just going to do a refresh. I'll do a hard refresh just to make sure we're getting no sort of hangover. So what we've got here is we've got the sort of global tag, AW is your ads, and then GTM. So you've got basically, we've got some duplicates. We're loading this G tag explicitly in the HTML. So we're loading this G tag AW and it ends in 8814. So we're loading that explicitly in the HTML. We're also loading this, your Google Tag Manager, explicitly in the HTML. So we're loading both of them. The problem we've got is that your Tag Manager then goes on to fetch your ads 8814 again with more parameters. So if you look, these files are identical in size, 481 kilobytes, 481 kilobytes. Basically, we've duplicated this download. They're both going to run twice, maybe firing tags twice, which is not ideal. But this one's got different query parameters on it, so it's kind of effectively cache busted this one. This fix here is really simple. Just use Tag Manager to fetch all of these tags. So what I would do is completely get rid of this from your HTML. In fact, we can do that. Let's just blitz that out. Now when we load the page, we should see we only fetch Google Tag Manager. That's our conduit. And then that was responsible for fetching your analytics and your ads sort of tag as well. And this is a completely separate thing. That's just a page view, sort of like a beacon. So basically, remove that direct link to your tag manager. Sorry, to your ads tag, because tag manager is going to fetch it for us anyway. We can remove that duplication. Right, there we have it. So that lasted quite a while, actually. I'm going to get this video edited and trimmed down, remove any of sort of the dead air, and I will send over the email with additional reading, code snippets. What I'll also do is I'll put this on YouTube with sort of chapter markers, so you can jump into the bit about speculation rules, you can jump into the bit about Tag Manager. And then if you've got any questions, just after you've watched the video, drop me an email and I'll answer any questions you've got. But I just want to say thank you. That was great fun. And I hope this has been helpful and good luck with the implementation. Thank you so much.